Hello, my name's Nigel Bowden. I'd like to welcome you to episode 6 of the Wi-Fi for Beginners podcast. This is a series of podcasts where we discuss the fundamentals of wireless LAN networking. In each episode, we'll take a look at a different aspect of Wi-Fi networking to help build your understanding and knowledge of wireless LAN networks. With each episode, I'll supply a set of slides where you can review some of the topics that we've covered in this episode in a little bit more depth. Don't need to actually review the slides as we're working through the audio presentation, but they may prove useful once you've listened to the podcast and want to review some of the concepts and the equipment that we've described. All of the recordings and supporting materials can be found at the website, which is wififorbeginners.com. In the previous 2 episodes, we've been covering Module 2 of our series. Module 2 covers the fundamentals of RF theory. We've been looking at some radio frequency basics, which are essential to understand when you're learning about wireless LAN networking, and certainly when you need to design wireless LAN networks. In the previous episode, we looked at the basic unit of frequency measurement, which is Hertz, spelled H-E-R-T-Z, and Hertz is defined as 1 cycle per second. We looked at various multipliers which you can use with these units. We've got 1000 Hertz is 1 kilohertz, 1 million Hertz, 1 megahertz, 1000 million Hertz, 1 gigahertz. And we also talked about the fact that Wi-Fi networks operate in the 2.4 and 5 gigahertz frequency range. We also talked about the radio frequency spectrum, and we talked about the way that spectrum is divided up into a number of bands, including low frequency band, medium frequency band, shortwave band, VHF, UHF and SHF bands. And we also discussed the typical uses of each band. We also finished off by covering 3 very important RF concepts. We talked about coverage areas, which is the area which is covered by a signal transmitted by a transmitting station. We talked about propagation, which is the movement of an RF signal from the transmitter to the receiver, and we also discussed the concept of modulation, where we actually imprint data that we wish to convey on our RF signal between a transmitter and receiver. So, following on from the concepts of propagation, modulation and coverage areas, just want to talk about another radio frequency behaviour, which I think is very useful when considering how radio frequency signals travel between a transmitter and receiver. I like to call this the light bulb moment, and it's a good analogy to consider and to keep in mind when we're thinking about the way wireless LAN signals are propagated around a room and around a building. So the analogy goes something like this. Instead of considering a wireless access point suspended from a ceiling, you can think of a light bulb instead suspended from the same point on the ceiling. Could be something like a carbon filament bulb that's sitting there glowing away. It's been switched on and you can see the light around the room. The light travels in many different directions around the room, and depending on how close to the light bulb or how far away from the light bulb you are dictates the amount of light, the amount of signal, if you like, you see from the light bulb. And RF signals operate in exactly the same way. Similarly, the amount of light we see from the light bulb depends on whether we have a clear line of sight to the light bulb. If you imagine you're sat behind an obstruction, you still get light from the light bulb, but it's not as good quality and the level of light received is not as high. Exactly the same principles apply to wireless LAN radio frequency signals. If you're not in line of sight, you're behind obstructions, you're not going to get such a good quality of signal or higher received signal level. Also, we can think about different surfaces that reflect light, such as metallic surfaces, and in the same way radio frequency signals will be reflected off metallic surfaces within a room, which will impact the quality of the radio frequency signals that are received. The area where this analogy tends to break down is obviously we can't see light through walls and most obstructions, whereas radio frequency signals do actually penetrate and pass through obstacles such as walls. But in general terms, the analogy is very good. It's very much about having line of sight, clear line of vision, and proximity to the light source or the RF source in order to get a good quality signal. And if we continue to compare a light source with a radio frequency source, from a wireless LAN network. We can consider when thinking about walls and other obstructions, light may well pass through obstructions such as smoked or frosted glass, and we can still see the light on the other side of the obstruction. With RF signals, walls and other solid obstructions act in a similar way as light to smoked glass. We can think of RF signals to walls. We will still see them on the other side of the wall, but they're going to be significantly reduced, significantly lower quality. Another aspect to consider with RF is that as the frequency gets higher, the signal is less likely to pass through obstructions. It's getting more and more like light as the frequency rises, and this has a very practical impact within wireless LANs. Signals operating in the 2.4 GHz band operate at a lower frequency than those in the 5 GHz band, and so they will pass through obstructions slightly better than signals up in the 5 GHz band, and so they do actually appear to propagate over greater distances than 5 GHz signals. So we've covered a few key concepts there. Just to go over those again, we've got the reflection of RF signals, and we need to bear in mind that RF signals, like light signals, will be reflected off metallic surfaces, and this is a consideration when we're placing things like wireless access points. We've also covered the concept of attenuation, that as signals pass through obstructions, they actually lose some of their energy and they're reduced in their signal level. So as signals pass through things like office walls, doors, trees, their signal level will reduce as they pass through each obstruction. There's also another key concept we talked about in a roundabout way. We talked about the way that RF signals travel through space between the transmitter and receiver, and the further away that we get from the transmitter with our receiver, the lower the signal level that we receive. And this concept of signal level degrading and reducing over distance is actually known as free space loss. So RF signals naturally received at a lower level the further we move away from the transmitter, but this reduction in signal level is actually occurs in a predictable manner. We can actually predict it using a mathematical formula. Over a particular distance, we can accurately predict what loss we will experience as we move away from the transmitter, and this whole concept is known as free space loss. Very important concept that we'll talk about many more times later in this series. Earlier in this episode we talked about the concept of radio frequency bands. We talked about things like the long wave band, the medium wave band, shortwave band, VHF, UHF, and they all occupy different parts of the radio frequency spectrum. When we're talking about wireless LANs specifically, we're talking about Wi-Fi networks, we tend not to talk in those terms. We tend to talk just about the 2.4 GHz band and the 5 GHz bands. These are two bands which are used solely for wireless LAN networking. So what do we mean by a band? A band is a range of frequencies that we can use for wireless LAN networks. So for instance, in the 2.4 GHz band we might consider the frequency range from 2.412 GHz up to 2.462 GHz. That range of frequencies is the range of frequencies we can use in the 2.4 GHz band. And similarly, there's a whole range of frequencies we can use in the 5 GHz band for wireless LAN networks as well. Each of the bands that we use occupies a very wide range of frequencies, and we don't actually use the entire range of frequencies each time we transmit with a wireless LAN access point or a wireless LAN client. What we do is we break the band down into smaller chunks of frequency which are called channels, and typically in wireless LAN networking we have a channel width of 20 MHz, so we will have a number of 20 MHz channels which fit within a band. And one thing to consider about the Wi-Fi bands, so that's the 2.4 GHz band and the 5 GHz band, these are what we call unlicensed frequencies. Unlicensed means that they are free to use, anyone can use them, they don't need to purchase a license from a local regulatory authority to use those frequencies. Anybody who has got the right equipment can actually use those Wi-Fi bands for anything they like. So this means that the bands which are used for wireless LANs, the 2.4 and the 5 GHz bands, they're actually used by other services as well. So for instance, we've got Bluetooth devices, we've got things like baby monitors, we've got radar systems, we've got things like security cameras. They're all using these unlicensed frequency bands for other services, and they're operating on exactly the same frequencies as the wireless LAN networks that we're deploying. We need to be aware of these, and we need to understand how to detect and to engineer around these coexisting services. Just briefly looking at the 2.4 and 5 gigahertz band in a little bit more detail, the 2.4 gigahertz band was originally the most popular band. It had the lowest cost of components. Because of the slightly lower frequency, the 2.4 gigahertz band, signals tended to travel slightly further. It had better penetration through obstructions, and in early wireless LAN networks, coverage was the main concern. So it was all about getting signals to go as far as they could, and 2.4 gigahertz band lent itself to this a little bit more than the 5 gigahertz band. Unfortunately, because of the popularity of wireless LANs, the number of devices on that band and other services such as the ones we talked about before, we got microwave ovens and security systems, all these other things. Because of that, 2.4 gigahertz is actually now starting to become considered a little bit of a junk band. There's so much on there now because it's all unlicensed. Anybody can use it for all these different purposes. It's actually getting a little bit too noisy, and when you've got mission critical systems that you want to deploy on there, it's not as reliable, and it's starting to become a little bit of a second class service compared to 5 gigahertz band. Also, the thing that was its benefit originally with the better penetration through walls and better distance coverage is actually works against it, because you've got neighbours who are on the same frequency band. You're more likely to have interference from neighbouring networks that can easily get through the obstructions between buildings. When we consider the 5 gigahertz band, that is now tending to become the default band to deploy all of your important services onto. It's growing in popularity very quickly now. It's got far less noise on the band because there aren't so many of the competing services. There's not so many devices that have been manufactured to work on the 5 gigahertz band apart from wireless LAN equipment. There's far less interference from neighbouring networks because 5 gigahertz doesn't travel quite as well. It doesn't get through walls quite as well, so there's less interference from neighbouring networks. And one thing to note about 5 gigahertz as well is that it is the only band which is supported by the latest 802.11 amendment. We've got 802.11ac, which you may well have heard of, which is the gigabit Wi-Fi standard. That is only supported on the 5 gigahertz band. There's no support for 2.4 gigahertz within that standard. So that just shows the way that the 5 gigahertz band is being considered the strategic way forward, and it really is now the band of choice that you should be considering when deploying enterprise networks. 2.4 gigahertz is very much second class citizen, much lower quality of service that you can offer around that. So when we're considering deploying a wireless LAN network, we need to take the frequency bands into consideration. We need to think, do my Wi-Fi clients support the 5 gigahertz band? Maybe we're going to be purchasing new wireless clients to operate on the network. We need to ensure that they provide support for 5 gigahertz. If we're going for lower cost devices, you maybe find that they only support 2.4 gigahertz on their wireless adapters. It's certainly worth checking, and obviously we need to make sure that the wireless access points that we're deploying will support 5 gigahertz. Generally, enterprise level wireless access points will support both 5 gigahertz and 2.4 gigahertz, which you can support at the same time. You've got two radios built into them, one for 5 gigahertz, one for 2.4 gigahertz, but it's essential that they have the 5 gigahertz support. The only time you generally won't see that is if someone is deploying very low quality, maybe consumer grade access points, which really shouldn't be deployed in an enterprise environment. So that's pretty much it for the end of this episode. Just a very quick summary of what we've covered in this module. This is the end of module 2 now, so we took a very quick look at what do we mean by RF. We went over the concepts of direct current, alternating current, and how an alternating current is transformed into a radio frequency signal. We talked about electric waves, magnetic waves, and how they combine to form an electromagnetic signal. We talked a little bit about the RF spectrum. We talked about the different bands within the spectrum, things like the low frequency band, the medium frequency band, shortwave bands, and covered what they mean and the types of frequency ranges that they covered. We had a brief look at some key RF concepts, talked about the coverage area of a signal, we talked about propagation of an RF signal, and we talked very briefly about the modulation of a signal. And then we went on to talk a little bit about RF behaviour. We talked about our light bulb moment, where we considered the analogy of a light bulb hanging from the ceiling and think about the behaviour of the light and how that might compare to a radio frequency signal when considering wireless LAN deployments. And then finally we took a very brief look at the Wi-Fi bands. We talked about the 2.4 GHz band and the 5 GHz band and the importance of leveraging the 5 GHz band within modern wireless LAN networks. So hopefully that's been a useful summary of basic radio frequency theory. It's a very important subject. It's quite tricky to get to grips with, and I'm sorry if it's a little bit of a dry subject to sit and listen to, but we will actually be returning to RF theory and diving in a little bit deeper in a couple of episodes, because this is such an important topic. You might like to get along to the website. I'm going to post a quiz that's going to test you on your theory of RF basics, so you can get along there and have a look to see how well you can do, how much you've actually learned from listening to the this particular module. Please don't forget to get along to the website. Go along to wififorbeginners.com and you can find the audio for all of the episodes that have been posted. You can find the slides that accompany the series. You can do the online quizzes, and I've also posted some useful resources such as books and other learning material that you might like to have a look at in your ongoing journey to learn more about wireless LANs. And also there's some information posted there about the CWNP program, the Certified Wireless Network Professional program, which I wholeheartedly recommend you take a look at and perhaps look at doing some of the certification qualifications on there to expand your knowledge of wireless LAN networking. Anyway, thank you very much for joining me. I hope this episode has been of some value for you, and look forward to joining you again on the next episode of the Wi-Fi for Beginners podcast.